dx over rad x, was it plus? Minus cube root x. Radicals suck. Let's get rid of radicals. I want to let x be some power of t that will cancel both a square root and a cube root. Remember, rad x is x to the 1/2 power. Cube root x is x to the 1/3 power. So what I want is I want x to be t to some power, call it n for the moment, so that when I multiply the exponents, 1/3 times n, right, I'm going to have t to the n to the 1/3, and I'm going to have t to the n here to the 1/2. I want n to be such a number that it cancels all the denominators. In other words, I'm going to let x equal t to a power that is the least common multiple of all the root indices. So I'm going to let x be t to the 6. Now the book gave you that hint. I would not, because I just told you how to figure it out. So what if some little jerk, me, asked you to integrate something like, say, cube root x plus 4th root x? You would let x be t to 12. Okay. Now there won't be any more radicals in the expression. This is called a rationalizing substitution because it gets rid of the irrational radicals. So dx is 6t to the 5th dt. So dx, 6t to the 5th dt, over, well, what is, if x is t to the 6, then square root x is square root t to the 6, that's t cubed, isn't it? So t cubed minus, and once again, if x is t to the 6, then cube root x equals cube root t to the 6, which is t squared. So t cubed minus t squared. Which is integral 6t to the 5th dt over t squared times t minus 1, which is integral of 6t cubed dt over t minus 1. How are we doing so far? Now what the hell are you going to do? Back in Calc 1, we saw that we can make the denominator into a monomial. So I'm going to let u equal t minus 1, then du is dt. So now I get the integral of 6 times. Well, t cubed is u plus 1 cubed. dt is du over u. So this is 6 integrals. U plus 1 quantity cubed is u cubed plus 3u squared plus 3u plus 1. I have that all over u du. And I guess you have to believe me on the u plus 1 quantity cubed. So 6 integrals u squared plus 3u plus 3 plus 1 over u. Du. So 6 u squared, the integral, well, let's just leave the 6 out there. That's 1/3 u cubed plus 3/2 u squared plus 3u plus ln absolute value u plus an arbitrary constant. I guess we ought to multiply the 6 through there. It makes it a bit prettier. 2u cubed plus 9u squared plus 18u plus 6 ln's absolute value u plus an arbitrary constant. And what is, well, where am I? U is t minus 1. So 2 times t minus 1 quantity cubed plus 9 times t minus 1 quantity squared plus 18 times t minus 1 plus 6 ln's, absolute value, t minus 1, plus c. And we're still not done. T wasn't the original variable. What is t? 6th root x.